Okay, hello and welcome to this video. We're going to be talking about how to write a net ionic equation and how to determine in which is the spectator ions and what is the reducing and the oxidizing agent. So those are the things that we're going to be looking at. If you watched one of the last videos that I did, and this is where this is coming from, we talked about how to write a single replacement reaction between aluminum and copper chloride. And we talked about the activity series and so forth, and the fact that aluminum needed to be stronger and higher on the activity series than copper in order for it to replace it. We also talked about that this is called a redox reaction, and there's actually a lot of the reactions we do are redox reactions. And they're a redox reaction in which when the charge on either the ion or the element changes from one side to the other on in the reaction. And so in this case, aluminum, which was your neutral element, has a 0 charge, but over here it has a 3+ charge. So it went from 0 to 3+. And so we called that an oxidation. Here would be the example. If you need more to look on that, go back to the last video in which I talk about how this happens. The same way with copper, it's a 2+ on this side, but when it comes over here, it now is the neutral atom of copper. And so it is a reduction that is taking place. So if you have an oxidation, we call that an oxidation is the loss of electrons. I showed you that. And reduction is the gain of electrons. So review there. If you don't, if that doesn't make sense, again, go back to the last video. Oxidation tells you which one is the reducing agent. The reduction is the oxidizing agent. So you'll need to remember that here in just a few minutes on there. So let's go ahead and just look at the reaction that we were working with. So I just rewrote the reaction for you. Now, when we go to write the net ionic, basically you're going to break the compounds into their ions, okay? And that has a name for it, and that is called dissociation, okay? And an example of when that happens, again, is when you're in a aqueous solution in an ionic compound, those ions actually dissociate, or if you think of it as they're just going to kind of break apart and float around in your solution that you have. And if you take that solution that is aqueous, and let's say you take evaporate the water off of it, then those ions are going to go back together to form your compound, okay? So that's called dissociation, okay? Is when they're broke apart within your solution, okay? And because of that, we can write our net ionics. So we're going to go ahead and get started on writing the net ionics. So again, two things. One, you're only working with the ions, and they must be an aqueous solution. The other thing is that they must be in a compound that is soluble in water, okay? And I went ahead and put both of these as being aqueous because I know that they're both soluble in water. Now, if you don't know that, you would need to go to your solubility table and look at it, and or it would be needed to be given to you within your reaction. Okay, so for this one, I'm going to just go ahead and give it to you. This is what it is. And so we're going to go ahead and write this. So I'm going to break it into its ions. Well, this is aluminum, the element. It's solid aluminum. And so it's not going to do anything. It's not going to break apart. So it's going to stay two aluminums. Okay. Now, when I come here with my copper, these are ions. They are an aqueous solution. They're going to dissociate. So I'm going to end up with 3 of the copper ions. And I'm going to get, this is the coefficient and your subscript, so I have 6 chlorine ions. Now that's on the reactant side. On the product side, same thing, aqueous solution, this is going to dissociate. So I have 2 aluminum ions. I have 6 chlorine ions. And then again, I have solid copper, which is the neutral atom of copper. So it's just going to be copper. Okay. Now, one thing I didn't mention, but of course, if you are not sure where I'm getting these just straight from the equation, then again, you might need to go back in and review. But if you just remember, we look at the anion portion of this. This has a -2 charge. Therefore, the copper, in order to be 0, has to have a +2 charge. Okay, the next thing that we're going to do is this is just your ionic equation. It's not your net ionic. So what we're going to need to do is we're going to need to figure out again those ions that are spectators, okay? Spectators. And what they are, again, those are the ones that are not doing any work in this equation. They're not doing anything. So they're spectators. Just as if you're, again, doing a group project and somebody in the group is not working. We can consider them a spectator. They're not doing the work. So we want to know who's doing the work. And the work people are going to give us our net ionic. Now, to find that, what we need to do is look at our equation and find somebody who's on both sides exactly the same. In other words, they didn't change. They didn't do anything. They're exactly the same before and after. Those are your spectators. Okay? And so when I go through here and look, aluminum, that changed. Okay? So I'm gonna leave it because that changed. Copper changed. Okay, one oxidized, aluminum oxidized, copper reduced. I have 6 chlorine. Those didn't do anything. They're exactly the same. So I just mark them out. And so chlorine is our spectator ion. You don't have to say 6 chlorines. I don't care about that. It's just that the chlorine ion is the spectator. So everything that's left becomes your net ionic. And so this is the part that is really taking place in the reaction. This is really the work that is going in to make this reaction occur, which is aluminum going from its solid form to an ion and copper going from an ion to its solid neutral state on that. Now, again, back to what we talked about earlier on this, we said that if it is the oxidation taking place, oxidation is a loss of electrons, then that becomes our reducing agent. So in this case, aluminum is our reducing agent, okay? And if it is a reduction, which in this case we talked about was going to be the copper, this is our oxidizing agent, okay? And that is our net ionic that we wanted. So we can see that really the only thing that's doing the work in this problem is the aluminum and the copper. And if you think about it, when we talk about single replacement reactions, on that, what we're looking for is the metal going to replace the metal in this case, in this reaction, okay? Okay, so that is how we write net ionics.